Hey guys, welcome back to the channel. This is going to be a complete video on thermodynamics, and our focus is going to be first law of thermodynamics. Now, the main reason why I say it's going to be a complete video of first law of thermodynamics because we're going to look at all the formulas in what first law of thermodynamics. And I'm going to show you how to solve problem using these formulas. I'm going to look at some exam possible questions and how you're going to see questions in the exam. So make sure you have your pen, your notebook, and your calculator to follow this video. It's very important to pay close attention. Now, if you are going to write organic chemistry exam, if you are going to write thermodynamics exam, then this video is going to save you a lot of time in your personal study. By the end of this video, you should be happy that you join this class. That's the assurance I'm giving to you. If this video is helpful, give it a like. And if you're not subscribed to the channel, please enable you to subscribe to this channel. So let's get into it. So the first thing, we are going to look at what various formulas. So now the first one we're going to look at is what? Volume, work. So we are still going to use the other side. So pressure, volume, work. And pressure, volume, work is what? W is equals to minus P change what in V. This is called pressure, volume, work. So in thermodynamics here, this is the first formula you need to understand. This is what is the work done. Again, this is work done. Then this is what is the pressure, and this is what change in volume. Again, so this change in volume is equal to what V2 minus what V1. Again, and there are two units you need to pay close attention to. Now, if the question is what? If the question gave pressure as ATM, and the volume is what? Is liter. Understand that you need to convert ATM liter because work also P change what volume, right? So it's a question. Now, pressure will be in what? In ATM. And volume will be in what? In liter or dm cube. Just please pay close attention here. So if you solve it here, the unit you're going to get is what? ATM what? Liter. Do you understand? Now we need to convert ATM liter to what? To joules, because the unit of work is what? It's joules. Do you understand? The unit of work is what? It's joules. So 1 ATM liter is equal to 101.33 what? Joules. Again. So 1 ATM liter is equal to what? 101.33 what? Joules. So this has to convert what? ATM liter to what? To joules. Do you understand? Now, why is your questions? Pascal will be given to you, and meter cube will be given to you. So I have this on there. Pascal meter cube. Now, Pascal meter cube is also now what? Joules. So for 1 Pascal, in the sense that when the pressure is what? Is P, is Pascal, and the volume is what? Is meter cube. Now you are going to have Pascal meter cube. Do you understand? And 1 Pascal meter cube is equal to what? 1 joules. So you have to pay close attention to this other one here. And the reason why here is minus is because of what is expansion. So we are talking about expansion work done. In thermodynamics, when we look at the work done, we are talking about what? Expansion work done. Do you understand? So that's why there's negative sign here. So the next thing I want to look at is called isothermal reversible expansion. Again, isothermal reversible expansion. Isothermal reversible expansion. Again, in isothermal reversible expansion, here we have W is equal to minus nRT ln V2 about V1. Again, or you can say W equals to what? Minus nRT ln P2 about P1. Again, so the two of them are work done. Now this one is when temperature is not be given to you. Do you understand? When pressure and volume is only given to you, that's when you use this formula here. Now, if you are not talking about temperature, and we know the numbers of mole, we are going to use this formula here. Do you understand? N is what? Is the mole. R is what? Is the gas constant. So R here is equal to 8.314 joules per mole per Kelvin. Again, joules per mole per Kelvin. Now T is what? Is the temperature, and the temperature must be what? In Kelvin. Do you understand? T must be what in temperature. Now, in some question, volume will be involved or pressure will be involved, depending on what you have been given. That's what I'm going to make use of. Do you understand? So the next one I want to look at is what change in internal energy. Change in internal energy. Change what internal what energy. And change internal energy is what statement of first law of thermodynamics here. Change in internal energy, which is what D is equals to what dq plus what w. I get this is called change what internal energy. Change internal energy equals to what the quantity of heat plus the work done. I get. So this is the what general what formula. I get. This is what is general what formula here. Now look at something here. Now we have two types of work. So we have to focus now. Let's focus on work done. I get work done. Work done. I get. Now we have two main types of work done. We have what called expansion work done and what compression work done. So we talk about expansion. Expansion. Now expansion means that work is done by the system. Work is done by the system. Work is what done by the what system. And when work is done by system, W is what is negative. It's okay. Please pay attention here. So expansion. Now when we talk about expansion, work is done by the system. And whenever work is done by system, it's called what? Expansion. And is what is negative. Just only pay attention to this other one because you are going to see problem under this one here. The next here we have what? Compression. Compression. Again. Now compression work is done on the what system. Work is done on the what on the system. And when work is done on the system, W equals to what? Positive. Again, work is equals to what? Positive. So you have to work pay attention. Expansion, compression. It's very important because I want to see question in the exam. Now this is called work done because this one here. Now learn about Q. Heat, quantity of heat. Quantity of what? Of heat. Now, when it comes to what quantity of heat, now heat can either be what absorbed or given out. So it can either be exothermic what reaction. So here you can say exothermic reaction. Exothermic what reaction. In an exothermic reaction, heat is what is lost. It's called heat loss. Heat lost by the what system. Heat lost by the what and by system. And whenever it is lost by the system, Q is what is negative. So when it is lost by the system, so it is what exothermic reaction and is what is it is negative. Do you understand? So we also have what called endothermic reaction. So we're going to do what? Heat gain by the what system. Heat gain by the system. And whenever it is gained by the system, it is absorbed. You understand? So when it is absorbed, Q equals to what? Plus change in V. It's okay. Change is what is positive. Do you get that? So you have to what? Under change in thermodynamics here, you have to know these two things here, very important. And this what? Exothermic and what? Endothermic what reaction. Now, another thing you want to take note here is that we have what? At different processes. We have called at isothermal process. We talk about isothermal process. Do you understand? Now, change in E is equals to what? 0. Please pay attention to this in here. Please copy them down. It's very important. At isothermal process, then change in internal energy is always equals to what? 0. We are going to see how they are going to ask questions in the exam because we are going to do a lot of questions in this video here. At isothermal process, change in E, which change in internal energy equals to what? 0. So they will ask you what is change internal energy in isothermal process. Now, once you hear that stuff, isothermal process, change equals what? Zero. That there's no change in what internal what energy. Do you understand? Now, another thing I want to look at is what? At diabatic process. It's okay. At the diabatic process here, there's no exchange of it between the system and what and so on. There's no exchange of what thermal energy. There's no exchange of what of thermal what energy. So when we talk about adiabatic process, change in Q is always equals to what? Zero. Change in Q equals to what? Zero. Please pay close attention because I will see them in the exam. Change in Q is equals to what? Zero. In adiabatic what process. There's no exchange of thermal energy between the system and the what surrounding. Do you understand? Now, the next one I want to look at is what? Isochoric process. Isochoric process. Now, we talk about isochoric process at constant volume. Right, at constant volume. So when there's no change in what in volume, then my W is equals to what? Zero. Do you get that? So this when the state occur or the process is what at constant volume, there's no change volume. W is equals to what? Zero. So that what taking of 1, 2, 3 is very important because I always see them in the what in the exam. Do you get that? So we are talking about change what internal energy. The next one to look at is what? Heat capacity. Heat capacity. Okay, heat capacity. Now we have two types of heat capacity. We have heat capacity at constant volume and heat capacity at what constant what pressure. Do you understand? So I've done a complete video on all these derivations. So you can check my channel or check the playlist on what thermodynamics. I will see this derivation. So here we have CV. Now CV means what? Heat capacity at constant volume is equal to change in internal energy or change in temperature. I get. So from here now, they can ask about calculate what change what internal energy. So if you want to make delta E the solid formula here, so here we have delta E is equal to what? NCV dt. Now most times when the mole is not being given to you guys, if the mole is 1, because N represents what? Mole, right? If the mole is 1, you should what? Ignore this one here. So going to be change equals to CV change T. I get it. But in some questions, the numbers of mole will be given to you. So that's why you have what? That's why you have N. N change equals to N CV change what in T. You have to see how we're going to solve problem with so that one here. Do you understand? So now this is called heat capacity at constant CV. CV equals to what? Heat capacity. Heat capacity at constant what? Volume. I get heat capacity at constant what? Volume. And is what? Joules per mole per Kelvin. It's okay. Joules per mole per Kelvin. So that is unit. Joules per mole per Kelvin. You understand? Joules per mole per Kelvin. Now, before we continue, if you have stayed this video here, till this extent here, please, I want just give me little. Let me just take just few seconds of your time. Please, if you have not liked this video, please do well to like this video. And if you are not subscribed to the channel, please endeavor to subscribe. That is the only way you can support me in the growth of the channel. Please, if you have not done it now, please just give this video a like. That is what like you are actually telling me that this video is helpful. And you can still go one step ahead and say, okay, because this video is helpful. You get that one will actually communicate more to me that this video is actually what helping you. Do you get that? So if this video is helpful, leave it at the comment section. And if you have not liked this video, please endeavor you like. If you're not subscribed, please join by what subscribing to this channel. Okay, let's move on. So here we are done what heat capacity at constant volume. Now this is how we call heat capacity at constant pressure, right? So Cp equals to what? Change in H or change in T. This is called heat capacity at constant what? Pressure. Again, so if you want cross multiply, so going to be change in H equals to what? NCP change in T. Of course, if the mole is not being given to you, you can ignore the mole, right? But if the mole is being given to you, you can what? Play NCP change what? T. Do you understand? Now, The next thing we want to look at is the relationship between CP and what? CV. So there's a relationship. The relationship here is what? CP equals to what? CV plus what? Idea. R is what? Is the gas constant. You get? So these are the various formula here. Now, next thing, the last formula we are going to look at before we can start solving problems is called adiabatic expansion. Do you understand? Formula. Adiabatic expansion formula. So I will go to my place here. Adiabatic. Adiabatic expansion. So here we have the adiabatic what expansion. Do you understand? So there's a way these formulas are being derived. You get so probably this one they are going to ask to derive one or two of this formula in the exam. So I will encourage you to go check my complete video on the derivation, how to get derivation. Do you understand? But in this video here, I just want to give you the formulas. So the first formula here is what is the relation between pressure and volume. Here we have P1 V1 lambda equals what? P2 V2 is okay. Lambda. Do you understand? So this one is what relates what pressure and volume. Do you understand? So here we have this lambda here. This one is called adiabatic constant. This one you are seeing is called adiabatic constant. So the next thing is what is B. We have T. You have what T1 or T2 equals what V2 or V1 lambda minus 1. Right there. Lambda what? Minus 1. Adiabatic constant. Right there. So this is the second formula here. T1 over T2 equals what? V2 over V1 lambda minus what? 1. Then the last one, C1 lambda P1 1 minus lambda equals what? T2 lambda P2 lambda minus 1 minus lambda. Do you understand? So these are the three basic formulas I want to use when it comes to adiabatic expansion. Do you get that? When it comes to adiabatic expansion. When it comes to adiabatic what expansion. So now you have to take note of all these formulas here. I will try as much as possible to compress them in that place here so that when we are solving, just look at those formulas. Do you understand? So I will compress them here. Let's look at what the first question 1. But here are the summary of all the formulas you need to know. So what you want to do here is so copy them out and master them. Now, whenever you see a question under the first law of thermodynamics here, now the question will determine the formula you are going to make use of. You get that? By bringing out what all the parameters. So from 1 to 10. You get. So now let's start squeeze them to solve questions. So let's take question 1. Let's say that a system expands from an initial volume of 2.5 meter cube to 6.7 meter cube against a pressure of 10 exponential minus 3 Pascal. Determine the work done by the system. Do you understand? So solution here. Now, therefore, before you start looking for a formula to make use of here, now, therefore, write out your parameters. From there, now you have a clear view of the kind of formula you are going to make use of. So now, this is expand from initial volume, right? So my initial volume is called V1 is equals to what? 2.5 meter what cube. Now, then to what? So V2 equals to what? 6.7 meter cube, right? Then the pressure is what? Is 10 exponential minus 3 what? Pascal. They are asking you the work done. Now, to you now, which one are we going to use? It's obvious we have to use what the first formula here, right? The first formula will relate what pressure and volume. Then essentially will calculate work done, right? So we are going to use what the first one. So W equals to minus P change what in V, right? We always say that W is equals to minus P V2 minus what V1, right? So let's impute what our values. So W equals to 10 minus 3 Pascal times here we have V2 which was 6.7 minus 2.5 meter what cube, right? So what I want to do here is, so going to be 10 exponential 3 Pascal times, okay, 6.7 minus 2.5. Then we have 4.2 what, meter cube, right? Times 4.2. So going to be 0 dot. So remember there is a minus here. So don't forget to put the minus. There is minus here. So going to be 4.2 exponential minus 3 joules, right? So remember, so which is going to be what? Pascal meter what cube. It's okay. Understand that 1 Pascal meter cube is equal to what? 1 joules. It's okay. You have to what? Know this thing here. 1 Pascal meter cube is equal to what? 1 joules. So it means that my W here is equal to minus 4.2 exponential minus 3 what? Joules. That is what? That. So that is the answer for the what? First one. Do you understand? So look at what the second question is that 1 mole of an ideal gas expand against an external pressure of 3.75 atm from an initial volume of 2.85 dm cube to a final volume of 6.12 dm cube. Calculate what the work done. You get. So solution. Like when I said, before you can start solving, knowing how to use this formula here, therefore you must understand the question. That 1 mole, that is my n, is equals to what? 1, right? 1 mole. Good. Of an ideal gas expand against an external pressure. So my external pressure is what? 3.75 atm, right? From an initial volume, that is my V1. My V1 is what? Is 2.85 dm cube. We also sent out as liter. Then final volume V2 is equals to 6.12 dm cube, right? So calculate what the work done. We are still going to use this first formula here, right? So it's going to be W is equals to minus P change your in V, right? Now the mole doesn't actually matter, so you can ignore it. So here you can now say W equals to minus P V2 minus what? V1, right? So what I want to do here minus my P is what? Is 3.75 atm times V2. My V2 is what? 6.12 minus V1 is what? 2.85, right? dm cube, right? So what I want to do here is what? Minus 3.75 atm times. So let's look at 6.12 minus 2.85. So let it be 3.27 dm cube, right? So when you multiply it, 3.75 times 3.27. So here we have what? Minus 12.2625 atm dm cube, right? atm or dm cube. Please, are you following? Now, remember, atm dm cube is not the unit of what? Of work. So you need to convert atm dm cube or atm liter to what? To joules. So what is the relationship? So here we have 1 atm dm cube or liter is always equal to what? 101.33 what? Joules. Do you understand? So you need to understand this here. So we are converting what? atm. So you are converting what? atm liter, atm dm cube to what? To joules. So it means that my W equals to minus 12.2625 atm dm cube over 1 times. So remember, you must arrange this in a way that unit must cancel out units when it comes to a conversion factor, converting from one unit to the other, right? So this guy will be down here. So here we have 1 atm dm cube, right? Here we have 101.32 joules. Do you see that? So atm dm cube cancel out atm what dm cube, right? So what do you have here? This times this. So here we have 12.2625 times 101.33. So here we have what? Minus. Remember this minus here minus 12.124.2.56, right? 56 joules. And then you can also convert it to kilojoules, but let me add joules here. So that is the what? That is the answer. Do you understand? Have this question. We have this question here. Please follow me closely here. They say that 2.5 mole of an ideal gas at 37 degrees centigrade is allowed to expand reversibly at constant temperature for a volume of 10 liter to 20 liter. Calculate the work done by the gas in joules and what and calories. So therefore, before you find the formula to use, let's copy out the parameter given to me. So by n equals to what? 2.5 what moles, right? Now, my temperature T is going to be what? 37 degrees centigrade. Remember, you always convert degrees centigrade to what? To Kelvin by adding 273 to this. Do you understand? So 37 plus 273. 37 plus 273 is what? It's going to be 310 Kelvin. Right? Now, at constant temperature for volume, so here we have V1 is equals to 10 liter, V2 equals to what? 20 what liter, right? So I ask you what is the work done. Right there, they ask you what is the work done. Now, what you need to understand here is that our here is equals to 8.314 joules per mole per Kelvin, or you can say R equals to what? 2 calories per mole per Kelvin. Do you understand? So you can either use any of this, right? You can either use any of this. So what are we going to make use of here? Of course, I'm going to what? Use the second one, W also minus N out ln V2 or V1. So why? Because I have the mole, I have what my R here, I have what my T, then I have what my V1 or V2. So I'll say W equals to minus N out ln V2 or V1, right? Equals to my N is what? 2.5. 2 minus 2.5 times 8.314 times here we have 310 ln V2 is what? Is 20 liter. 20 liter over V1 is what? Is 10 liter. It's okay. So what happened here? Liter and liter we want to go out, right? So here we have minus 2.5 times 8.314 times 310 times ln 2. So what you want to do here is to go and calculate and put your answer. So minus 2.5 times 8.314 times 310 times ln 2. So here our W here is equals to minus 4,466.189, right? It's 1898 joules. Just and it will be in joules because I'm using the first one here, joules, right? So now, if I want to convert to calories, I can use 2 calories here. You get so if I want to convert to calories, it's going to be W equals to what? Minus 2.5 times 2 times 310 ln 20 over 10, right? So we're going to be minus 2.5 times 2 times 310 ln 2. Do you understand? So minus 2.5 times 2 times 310 times ln 2. So we have W here. It's also minus 1074 2.378 calorie. Do you understand? So this is how to work to solve this question here. Hope it's useful here. Please, if you are following this video, leave at the comment section that you are following this video. And this video is, if this video is helpful so far, please leave it at the comment section. Please don't be like a grateful someone that you actually see something that is helping you, but you can actually comment that this thing is actually what helping you. It's so unfair. You get actually you're not actually paying. So the only way you show show support and like be grateful for what I'm doing for you, because this video is actually going to help you in your exam preparation. So it's only when you subscribe and you like this video, you get. I also leave it at the comment section that this video is helpful. Now you can also do it to what share this video with other of your friends so that other people can get to what see this video. So now we're going to look at our question 4. Now let's look at our question 4. Let's look at our question 4. So that find the work done when 3 moles of the gas is expanded reversibly and estimally from 6.1 atm to 1.5 atm at 25 degrees centigrade. So let's solve it together here. Like what I said, what you want to do is to what write out all your parameters. So they give me what n. N is what is mole, which is what 3 what moles, right? Now expand reversibly and estimally from. So here I have my P1 is equal to what 6.1 atm and my P2 is equal to what 1.5 atm. Now what is my temperature? My temperature is what 25 degrees centigrade. Remember you have to convert to what to Kelvin, right? So it's going to be 25 plus 273. What is the answer? So it will be 25 plus 273. What is the answer? Here we have 298 Kelvin, right? So which formula are we to use? Of course, we cannot use the first one. We cannot use the second one. We have to use the third one, right? So which is what? W equals to what? Minus nRT ln P1 over P2, right? Now my gas constant is gas 8.314 joules per mole per Kelvin. Do you understand? So let's substitute what our values. So maybe W here equals to minus. My N is what is 3. 3 times 8. R is what? 8.314 times. My T is what? 298. Ln what? My P1 is what? 1.5. 1.5 atm over what? Okay, P1 is what? My P1 is what? 6.1 atm over what? P2 is what? 1.5 what atm, right? So guys, that atm cancel out atm, right? So what do I have here? It's going to be equals to minus 3 times 8.314 times 298 ln let's say 6.1 divided by 6.1 divided by 1.5. Here we have 4.067, right? So what do you want to do here? So what? Increase your stuff here. Minus 3 times 8.314 times 298 times ln 4.067. So you have equals to minus 1042 7.399 joules. That is the answer. Now let's do unit analysis. Unit analysis, right? So let's confirm if our unit will always be in joules, right? So my N is what is mole. What is the unit of mole? Mole is mole, so it will be W here equals to what? Mole, right? Times. Now my R is what? Is joules per mole per Kelvin. So we have joules per mole per Kelvin times Kelvin, T is what temperature is what Kelvin here times. Remember here we have P1, P2, and P1 is what is ATM, P2 is what is ATM. So they will cancel that, right? So what do you have here? Kelvin will cancel per Kelvin, per mole cancel out mole. So here we have W equals to what joules. That is how I have good joules here. Do you understand? So that is it for this question 4. Now let me move to what question 5. So here we have question 5 and question 6. So I will solve the two of them together. Is that what is the change in internal energy of the system for a process in which the system absorbs 140 joules of heat from the surrounding and does 85 joules of work on the surrounding? Okay, now let me tackle some first solution. Right there. Now, when you say you should calculate the change what internal energy, so change what internal what energy, right? Let's see that what is change internal energy of the system for a process in which it absorbs heat. So Q. Now the when it is absorbed, is it exothermic or endothermic? I want to leave at the comment section. When it is absorbed, is it exothermic or endothermic? There is that it is absorbed, that it is what absorbed. It is absorbed of 140 joules of heat from the surroundings. The system absorb it. So is it exothermic or endothermic? Of course, it's endothermic. Whenever it is absorbed or taken in, or it is gained, it's called endothermic. I get. And whenever the gas is endothermic, Q is what is positive. Do you understand? But if it's exothermic, that is, it is given out, it is released or lost. That is what exothermic reaction, and Q is what is negative. So because they say that this absorb 140 joules of heat from the surrounding, so going to be minus 140 joules. Do you understand? Right? Then from the surrounding and does 85 joules of work on the surrounding. So yeah, when you say that this does 85 joules of work on the surrounding. So W. Now remember, work can either be expansion or compression, right? Now we talk about expansion. Work is done by the system. That is, work is done by the system. So that is called expansion. Work done by the system. Okay. And when work is done by the system, it's called expansion. The work is always what negative. Do you understand? Work is always what negative. So it's going to be minus 85 joules. Please understand this here, because this thing normally used to confuse students in the exam. Idea. Expansion, work is done by the system on the surrounding. Compression, work is done on the system by the surrounding. Do you understand? So yeah, the system is the one doing the work. So because system is doing the work, called expansion. And whenever it is expansion, then work is what is negative. You get? So which absorb it. So here I'm going to be positive here. Yes, positive. Just I'm say positive because it is what absorbs, so it's positive. You get? So what are we going to do here? So which one are we going to use here? We're going to use this one. Remember I tell you that the general formula is what? Delta E plus W. Do you understand? So here we have delta E equals what? Delta Q plus what? W. Do you understand? So here we already know our Q here. You just want to impute what our values. So here we have change E equals what? Delta Q which what? Plus 140 plus here we have minus 85, right? So what is the answer here? 140 minus 85. What is the answer? So here we have 140 minus what? 85. Here we have 55 joules. Do you understand? That is your answer. So you can pause the video and try and see if you can solve this for me. So let's go with question 2. So pause the video and try it for me. I'm going to give you some few seconds so you can pause the video and try it and leave your answer at the comment section. Okay, so a system gains 418.2 joules of heat. So a system gains. So change in Q is equals to what? Because it gains is what is positive plus uh 418 point what 2 joules, right, of it, and does so the cell also do the work. It's just similar to another thing here. So work done by the system is also what negative minus 313.5 joules. I did. They ask what is change, determine the change in internal energy. Delta E is what you are looking for, right? Delta E equals what Q plus W here, right? So you just want to impute it here, right? 418 point what? Point 2 plus minus 313.5. It's okay. 418.2 minus 313.5. So you have to use your calculator. 418.2 minus 313.5. You have 104.7 joules. That is the what? That is the answer. So we have solved this two here. I believe you now understood how to supplement like this. So the next one we want to look at, let's look at what the next question. Let's solve this question. It says find delta E, Q, and W if two moles of nitrogen gas at atm pressure expand isothermally at 50 degrees centigrade and reversibly to pressure of 1 atm. So solution. Now, what I want to look at is what delta E, right? They want to calculate what delta E, Q, and what and W, right? So now my N, what is my N? My N is what? 2 moles. 2 what? Moles, right? Then my P1 is equal to what? 3 atm, right? Then my P2 is equal to what? 1 atm, right? Then my temperature is what? 50 degrees centigrade. Of course, I want to combine to what? Kelvin, right? 50 plus what? 273, right? So 50 plus 273 is equal to what? 323 what? Kelvin, right? So, of course, now, because these three are linked together, we are able to relate down here. So delta E equals to what? Delta Q plus what? W, right? So this is what we are relating. It's very, very important here. Now, first of all, what is delta E? Right? What is delta E? Now, in isothermal process, delta E is what? 0. Right? So when I talk about isothermal reversible expansion, now change in internal energy at all is always equal to 0. So change in internal energy equals to 0. Isothermal process. And so if you see the kind of process in the exam, I say what? Calculate what change in internal energy at isothermal process. At constant what temperature, there's no change in what internal what energy. So that is equals to what? 0. So if you should apply this now, delta E equals to Q plus what? W, right? If here is 0 equals to Q plus W, right? Now let's make Q formula here. So it's going to be Q is equals to what? Minus what? W. So this is what you want to understand here. So our mission here is to calculate what? W here. To calculate W. So W here, which was the work done. Remember, if you're talking about expansion, remember here is already possible here, right? So if you're talking about expansion, so here we are using moles, temperature, and P1 and P2. You are still going to use this formula to calculate what W. Hope you understand. Because if you can get your work done, you have already got your heat. So in isothermal, now in isothermal reversible expansion, calculate what pressure, temperature, and moles. You are going to use this here. So you're going to be what? Minus N RT ln P1 or P2, right? So let's substitute what our values. W here equals to minus. What is my mole? My mole is what is 2 times my arrow. What is my arrow? 8.314 times my temperature is what? Is 323 ln. My P1 is what? 180 over what? My P1 is what? Okay, my P1 is 380. 380. My P2 is what? 180, right? 80 will cancel out this here. So my W here goes to minus 2 times 8.314 times 323 mean what? 3. So what I want to do here is to bring your calculator here. So minus 2 times 8.314 times 323 times mean 3. So you have W here equals to minus 5900.475 what joules, right? So that is going to be what my work done, right? So I'm going to what my data Q, my data E, and what W here. So what is my work done? Remember, what is my work done is what this guy here, right? So what is my it? Remember, it Q is equal to minus W, right? W here is only what minus. So what you go to be minus times minus, you go to be what plus. So going to be minus 5900.475 joules. Minus times minus is what is plus. So going to be plus 5900.475 joules. That is it. Consider as it is. So you want to see question like this in the exam. You want to see question. I have tons of questions regarding this one here, but time will solve more this type of what problem you get. So what you want to do here is to what? Make sure you go to your past question and see how you can what solve some other questions, right? So let's see the next question. Let's look at what the question 8. They say that 3 moles of an ideal gas. 3 moles of an ideal gas. So here they gave CV. Now what is CV again? Heat capacity at constant volume, right? At 10.08 tm and 0 degrees centigrade are converted to 20.08 tm at 50 degrees centigrade. Find beta E and beta H. You get. So now what I want to do here is solution. What you want to do here is this. So here my N is what is 3 moles. Therefore, write out all the parameters. So 3 moles. Now my CV, which was molar capacity at constant volume, is what 5 calories per mole per degree. And this per degree you also know what Kelvin. So you also know as Kelvin. Now, my P1, what is my P1? My P1 is what is 10.08 tm, and my T1 is what is 0 degrees centigrade. Of course, we convert what to Kelvin by adding 273. What 273 what Kelvin, right? Now my P2, what is my P2? My P2 here is what 20.08 cm, right? Then my T2 is what is 50 degrees centigrade. So what I want to do here is to convert to Kelvin. So 50 plus 273. 50 plus 273. Here we have 322 what Kelvin, right? So yeah, my arrow is what they gave to me is what 2 calories per mole per what degree, also known as Kelvin. So we don't use the degree. Do you understand? So therefore, let's calculate what delta E. Now when you have delta E, which is one here, delta E is equals to what NCV change T. It's okay, as easy as that. So here we have what change E equals to what my N. What is my N? My N is what 3. 3 times CV is what CV is what 5 times change it T. Remember, change it T equals to what T2 minus what T1, right? So it will be my T2 is what 323 minus T1 is what 273. Can you see that? So what I want to do here is to multiply it. So it will be 3 times 5 times 323 minus 272. So we have equals to 750 what joules. Oh yeah, 750 what calories, not joules. It's the calories. Can you see that? So we are putting this one here. We are calling this one here. Next, just what you should do is what change what enthalpy, right? So change the enthalpy is also what NCP change it T, right? Now here I only know my they only get me what my CV, but understand that I need to what calculate CP. You understand? Yeah. So now for you to calculate the data H, then change the enthalpy. Therefore, I must know what my CP, right? Now, but CP was not given to me. But I know that in this year, this is the relationship between CP and CV. So CP equals what CV plus what R, right? So when my CV, my CV gives me was what 5 plus my R is what 2. Going to be what 7 calories per mole per what degree per degree. Is okay. So this is what I'm going to use. So in the place of what this 5, I'll place what 7. So now will be data what EH equals to what 3 times 7 times 323 minus 273, right? So here we have what 2. We have 3 times 7 times 323 minus 273. So our data H is equals to 1050, right? So we should go to what calories. So that is it. So we have used 1, 2, 3, 4, 5, 6, 7. So we still have like 3 to go. Just that. So uh let's look at what next question. So now let's look at what the last question in this video. So they say that 1 mole of neon is expanded reversibly and adiabatically from 2.24 exponential minus 2 meter cube at 298 Kelvin to 4.48 exponential minus 2 meter cube, right? Calculate the final temperature and pressure of the gas if it is assumed to be ideal. And they give what CV. Heat capacity at constant what volume. Okay, now let's solve this. Now, before you can solve this thing, what you want to do here is what you write out all your parameters. Now, from the parameters given to you, that is when you know the formula to use. Remember, these are all our what formulas when it comes to what first law of what thermodynamics. So yeah, they say that the mole equals to what 1 mole, 1 what mole of neon. Now, my V1, so you can say V1 is equals to 2.24 exponential minus 2 meter cube, right? Then my C1 is what? Is 298 Kelvin. Now, when you're solving here, you must add speed and accuracy because your exam is you have less time to solve this thing. You get. So you need to be fast and need accuracy. Okay, so then V2 is what? V2 is 4.48 exponential minus 2 meter cube, right? Now essentially we'll calculate what the final what temperature, right? And pressure. So final temperature what and pressure. Be what they say you should what calculate. Okay, so CV is given to me to be what 12.25 joules per mole per watt per Kelvin. Now, if you look at the statement here, you see adiabatically. Now, these are our adiabatic what formulas. Okay, so when you talk about adiabatic formulas, now immediately you see adiabatically. It means that these are the formulas you are going to what make use of. You understand? So how do we start solving it here? Remember, because you're talking about adiabatical adiabatically. Now, you know, we have to calculate the adiabatical what or adiabatic constant. Yes, adiabatic constant, which is what gamma, right? Adiabatic constant is what gamma equals to what Cp or Cv. It's okay. Now, they only gave us what Cv, right? But Cp was not given to us, right? Now, but here we know our relationship. Cp equals to Cv plus what R. So it means that here we have Cv plus R over what Cv, right? Now, remember we are talking about joules. Joules here. That is my gas constant R is what 8.314 joules per mole per watt per Kelvin, right? So this is what I'm going to use here. So it's going to be what Cv is what is 12. So it's going to be 12 plus 8.314 over what 12, right? So do what I want to do here. So I want to have 12 plus 8.314, right? Divided by what? 12. So you have 1.693. Do you understand? 1.693 what 3. It means that I've got this one here. So the next one to do now, let's look at what the formula we have to apply here. Now I know what my V1 and V2, right? Now I know what my T1. I'm going for T2, right? First of all, I'm going to calculate T2. So then I'm going to use the relation between volume and temperature. Volume and temperature. Now, this is what volume and what pressure. We are not going to use it here. Here we have temperature and volume. So that is what volume and temperature. So this is what we are going to make use of here. So we say using T1 or T2 is equals to what V2 or V1, right? Gamma minus what 1. Can you see that? So this is what I'm going to make use of here. So let's substitute what our values. So my T1, what is my T1? My T1 is what 298. So 298 over T2, which I'm looking for, right? Equals to V2 is what? V2 is what? 4.48 exponential what? Minus 2 over V1 is what? 2.24 exponential minus 2, right? So then that will be what? 1.693 minus what? 1. So I'm going to evaluate the whole of this guy here. So let me evaluate this one here. Here we have 4.48 exponential minus 2 divided by 2.24 exponential minus 2. 1.692 minus 1. So everything here, if you should use your calculator to evaluate the whole of this one here, I want to have 298 over what T2 equals to what 1.6166. It's okay. So that when you evaluate the whole of this one here, so now what the make it T2 is a formula here. So T2 is going to be equals to 298 over what 1.6166. Do you understand? So punch your calculator here. So you have 298 divided by the answer. Here we have 184.33 Kelvin. Do you understand? So that's my T2. My T2 now is what? 184.33 watt Kelvin. That is it. Do you understand? So when you evaluate this one here, this is what I'm going to get. So now the next thing we want to do is to calculate what T2. And there are different ways to calculate it. So I want to write this place here. So you can pause the video and copy all things out. You understand? If you have any question, leave at the comment section that you have any question. If there's any question that is bothering you that you would like me to solve, please also leave it at the comment section. And if this video is helpful, please leave it at the comment section that this video is helpful. You get that? That will be what my motivation to know that the video is actually what's helping you. And if you're not subscribed to the channel, please hit that subscribe button now and subscribe to the channel. You get? So let's look at what how do we calculate T2? How do you calculate final pressure? How do you calculate final pressure? So if you check very well here, no initial pressure was given to me, right? So I'm going to use this general gas equation, no, the ideal gas equation, which what PV equals to what nRT. I get. Now I'm talking about T2, P2, final pressure. Just final what pressure you get. So that means final pressure here. I'm going to say P2 V2 equals to nRT2. Do you understand? Do you understand? Now, because I know what I'm looking for, P2. I know my V2. What my V2? My V2 is this. I know my N. My N is what is 1 mole. My R is going to be what now? What my arrow? What will now be my arrow? Right? What will be my arrow? My arrow. I'm going to use this one here. 8.314 joules per mole per Kelvin. It's okay. Now the main reason why I'm going to use one here because I'm already in meter cube. You get? It's already in meter cube. My volume is already giving you in meter cube. Just because joules, if you look at joules here, joules equals what Newton meter. I did Newton what meter. So it already what relates. So I want to use 8.314 joules per mole per watt per Kelvin. This is what I'm going to make use of here. It's okay. I'm going to my gas costs are going to be 8.314 joules per mole per Kelvin. And the main reason why I'm using joules per mole per Kelvin is because this volume here is only in meter cube. Okay. And joules is what Newton meter. So meter is already here. So indirectly here, joule is already Newton meter. So meter is already here. So I'll do what I'm using. So I'm not going to use 0.0821 ATM liter per mole per watt per Kelvin. It's okay. I'm not going to make use of this one here. Just I'm going to make use of what? Joules per mole per watt per Kelvin. So if that be the case, let make P2 the subject of what formula, right? So making P2 the subject formula here. So my P2 is going to what nRT2 over what V2. Just so what will happen here? My N is what? My N is what is 1 times 8.314 times my T2. What my T2? T2 is what I've already calculated, right? So it's what 184.33 over V2. Now what's my V2? V2. My V2 is what 4.48 exponential minus what 2, right? So going to calculate and I'll get your answer here. So it's going to be 34208.0. You understand? So what will now be the units? What will be the unit of what? Of pressure. The unit of pressure is going to be what? Newton per meter square. Newton per meter square. That's going to be the unit. It's okay. Normally pressure is what? Newton per meter square, right? That is what pressure, because normally pressure equals what? Force over what? Area, right? So force is what is Newton, area is what is meter square, right? So that's why we have what? Newton per meter square. So here we have Newton per meter square. That is what my pressure. Do you understand? So that is it for this calculation. That is for this calculation. So now, but next video is coming up for this adiabatic, because we're going to solve the last problem under adiabatic expansion before your exam. You get so if you are still not good in some certain areas when it comes to what thermodynamics, please leave at the comment section that this is your problem. So let me see how I can fix that issue for you. Now, I have a playlist on thermodynamics. I have a playlist. So you can go check out the playlist, then check out the videos, the topics you are still having issues with, and we'll go watch that video here. So you see on the screen now, some videos, topics. Then you also check what the playlist. So I will leave the playlist here for you. Check out the playlist, then look at those things you're not still good at, then go into it. Now the main reason for this video here or this class is to ensure that at your own comfort of your home, when you prepare for exam, you can still see that at your own comfort of your own and still prepare very well for the exam. Do you get that? So next video is coming up. Please make sure you don't miss out the next class before your exam. Thanks for watching. So I'll see you there.